To evaluate, the first thing you want to remember is that all inverse trig functions are angle measures. So we want to let tan inverse of u equal alpha and the cosine inverse of v be angle beta. Ultimately, we will apply the sum difference property to evaluate this expression. To find the answers to sine of alpha, cosine beta, sine beta, and cosine alpha, we're going to need to build triangles on the bow tie. Let's start with alpha equals tan inverse of u. This will allow us to find sine and cosine of alpha. Applying tangent to both sides, we find that tangent of alpha is equal to u. This u can be put over 1 to make the opposite and adjacent stand out to help us build our right triangle on the bow tie. The u is the opposite, and the 1 in the denominator is the adjacent. Now we'll use the Pythagorean theorem to find the missing hypotenuse. So solving this equation, we end up with m equal to the square root of 1 plus u squared. Now that we know the hypotenuse, we can find the answer to sine of alpha. SOHCAHTOA. Sine is opposite over hypotenuse. So this is u over the square root of 1 plus u squared. To rationalize, in other words, get rid of the root in the denominator, let's multiply the top and bottom of this fraction by the square root of 1 plus u squared, which results in this. Moving on, the cosine of alpha, SOHCAHTOA, is adjacent over hypotenuse. So it will become 1 over the square root of 1 plus u squared. Once again, let's rationalize by multiplying the numerator and denominator by the square root of 1 plus u squared, getting this. We now know the sine of alpha and the cosine of alpha, so let's use beta is equal to the cosine inverse of v to find the rest. Applying the cosine to both sides, we have the cosine of beta equals v. Putting that over 1, we can see the adjacent over the hypotenuse to build our right triangle on the bow tie. So v is going to be my adjacent and 1 is the hypotenuse. Let's use the Pythagorean theorem to find the missing side. Getting the m by itself, let's subtract over v squared and then square root both sides. The hypotenuse m is the square root of 1 minus v squared. Now we can find the sine of beta in SOHCAHTOA, that is opposite over hypotenuse. So the sine of beta will equal the square root of 1 minus v squared over 1, which simplifies to this. We've now found everything we need to evaluate the original expression. Here's our formula, and the sine of alpha minus beta. Let's substitute in for the sine of alpha what we found. Substitute in what we found for the cosine of beta, minus, substitute in the sine of beta, and lastly, substitute in the cosine of alpha. We do have the answer, but now we need to simplify this answer. Let's start by multiplying those first two together. That v is over 1, so multiplying straight across, this is what we have. Then we have minus. Then let's multiply the last two pieces together. Again, that square root of 1 minus v squared is over 1. So let's just multiply straight across. Next, we see that we have two fractions with common denominators. Both denominators are 1 plus u squared. So we're going to be able to combine the numerators over that common denominator 1 plus u squared. To simplify the fraction, we want to look for what's in common to both pieces in the numerator in hopes that we can factor and cancel. Notice in the numerator that I've highlighted in gray, they both have a square root of 1 plus u squared. So let's factor the square root of 1 plus u squared out of both of the gray ones. And then what we have left is uv in that first gray one. And then in the second gray one, we have left the square root of 1 minus v squared. In both the numerator and denominator, we have a 1 plus u squared. But we need to emphasize the exponents on the 1 plus u squared. So I've placed a set of parentheses around the 1 plus u squared in the denominator, and that is to the first power. In the numerator, the square root is the same as to the power of 1/2. Now that we have like bases, we want to subtract exponents. So we're going to subtract 1 that's an exponent and the 1/2 that's an exponent. And that leaves us with to the 1/2 power. So we have more in the bottom than the top. So the 1 plus u squared is to the 1/2 in the denominator. From there, we could rewrite to the 1/2 as the square root of for our final answer.